A voltmeter having a resistance of 1800 ohm is employed to measure the potential difference across a 200 ohm resistor which is connected to the terminals of a DC power supply having an EMF 50 volts and internal resistance 20 ohm. What is the percentage decrease in the potential difference across the 200 ohm resistor as a result of connecting the voltmeter across it? Here 200 ohm resistor is connected to a cell of EMF 50 volts and resistance is 20 ohms. Now let us consider the figure. This is a cell and this is a 200 ohm resistor. Cell EMF is 50 volts, internal resistance is 20 ohms. Now a voltmeter is connected across this 200 ohms. So without voltmeter and with voltmeter, now let us calculate the voltages. So current passes like this through this circuit. Say I1 is the current. So I1 is given by 50 divided by, these two are said to be connected in series, 220. Now potential difference across this resistance, if I call it as V1, V1 becomes I1 into R 200, that is 50 by 220 into 200. So if I cancel 1 0, now this becomes 1000 by 22 volts. This is the reading of the expected potential difference across these two. Now second case, same thing, but a voltmeter is connected in parallel to 200 ohms. Connect a voltmeter. Resistance of the voltmeter is 1800 ohms. Now in this case, imagine current through the circuit is I2. Now I2 is given by 50 divided by this 20 internal resistance plus these two are connected in parallel, 200 into 1800 divided by 1800 plus 200, 2000. Now if I cancel 200 and this 10 times, this 0 gets cancelled. So 50 divided by 20 plus 180, 200. Now potential difference across this one, V2 if I call, that is the voltmeter reading. V2 is equal to I2 into 200. So we need the potential difference across this one. Now 200 and 1800 are connected in parallel, so it is I2 into 180 ohms. The effective potential difference across this one, because I2 is the current coming here, the equivalent resistance of the combination, it is 180. So it is 50 by 200 into 180. Here I can cancel this 0, 2 into this one 9 times. That means 45. Now what is the percentage change? V1 minus V2 by V1 into 100. So it is 1000 divided by 22, that is the V1 actual expected, minus 45 divided by 1000 by 22 into 100. So if I simplify this one, LCM is 22, 1000 minus 45 into 22. So it is 990 divided by 1000 by 22 into 100. Now 22 and 22 gets cancelled. So this becomes equal to 10 divided by 1000 into 100. So this is total 1000. So remaining is 1. There is a 1% decrease in the voltage because the voltmeter is connected. So the presence of the voltmeter changes the resistance across this one. That effective resistance already we calculated. This is the effective resistance 180. So in the second case, voltage is current multiplied by the effective resistance 180 value, 45 volts. Without voltmeter reading is 100 by 22. With voltmeter reading is 45 volts. So percentage change, if I calculate this the value,